I'm going to solve question 1D. So this is from 8B, and I want to show you how to do this. So the first thing I'm going to do is find my stationary points, and then I want to know what kind of stationary points they are. Are they are they maximums, minimums, or points of inflection? So let's have a look at this. So the first thing I'm going to do is find my derivative. So dy dx. I want to find where my stationary points are. So remember, when the gradient is 0, it is a stationary point. So I get negative 3x squared minus 6x plus 9. So the first thing I have to do is solve this. So I'm going to take out my common factors. I'm going to take out negative 3 because I need my first term to be positive. So that gives me plus 2x plus 3, minus 3. All right, so I want you to think about what two numbers add to the middle and multiply to the last. Hopefully you can see that is plus 3 and minus 1. So my x solutions are negative 3 and positive 1. So now I need to put these back into my original equation to find the y coordinates. So then y is negative 3 cubed minus 3 negative 3 squared plus 9 negative 3 plus 10. I'm just going to move the whole screen over a little so I don't need to do that. So negative 3 squared is negative 27, but I've got another negative out the front, so it's positive 27. Negative 3 squared is 9 times negative 3 is negative 27. So far we have 0. Let's ignore that. 9 times negative 3, again, is negative 27, plus 10, so my answer is negative 17. So that makes my turning point coordinate negative 3 and negative 17. Let's do it again with 1. Negative 1 cubed minus 3 times 1 squared plus 9 times 1 plus 10 gives me negative 1 minus 3 plus 9 plus 10, which gives me negative 4 plus 9, which is 5, plus 10, which is 15. So that makes that coordinate, actually, let's just zoom out for a second. That coordinate becomes 1 and 15. So let's just get a little highlighter out. So these are the two stationary points of this graph. Now what we need to do is determine the kind of stationary points that they are. So what I'm going to do is substitute, well, first of all, let's just find the second derivative. So my second derivative, I'm going to take my first, so I'm going to take my actual derivative and then derive that. So I get negative 6x minus 6. So what I'm going to do is I'm going to take each one of these turning point x coordinates and put it into the second derivative and see if it's greater than or less than 0. So I have negative 6 times negative 3 minus 6. So I end up with 18 minus 6, which gives me 12. So 12 is clearly greater than 0. Let's do it with 1. So I have negative 6 times 1 minus 6. So I've got negative 6 minus 6, which is negative 12. Okay, and negative 12 is clearly less than 0. I'm going to change color again. All right, so now we know from the last question, we talked about the fact that if it's greater than 0, that makes it a minimum turning point. If it's less than 0, it makes it a maximum turning point. So that is why we use the second derivative to tell us the nature of the secondary point, the stationary point. Now, what I said before is that you can almost skip some steps because we know that this equation, oh geez, what am I doing? The original equation, why am I still drawing through the equation? The original equation is a negative quadratic. If you recognize it looks like this, you already know the first one is a minimum and the second one is a maximum. So if you are asked to prove it, you still need to use your second derivatives, to prove it. But if you don't need to prove it, you can use your knowledge of graphs to just make a judgment. So please do that. All right, I'm going to leave you to do your work. Good luck, and please email me with any questions, and I will see you on Friday.